Hi everyone, this is your struggling CS student, and today let's solve another LeetCode problem of the day. Let's take a look at today's problem, 2536, increment submatrices by 1. It's a give or take 1600 rated question. So let's take a look. You are given a positive integer n, indicating that we initially have an n times n zero index integer matrix filled with zeros. Okay. You're given a 2D array query where for each query of I, you have the row and column of two coordinates, and you should do the following operation. You should add 1 to every element in the submatrix in the top left corner of row 1, column 1, and the bottom right corner, row 2, column 2. That is, add 1 to matrix xy for all x between row 1 and row 2, and column between, what should I say? The y's between the columns, yeah, in the given range. Then you need to return the matrix after performing every query. I'm trying to see if like an n-square solution can work. Obviously, this is like kind of pointing towards like how should I say, difference array. So if you know difference array, what it allows you to do is allows you to perform range updates in constant time in an offline manner. Yeah, in an offline manner, by allowing you to pre-compute the updates that are made to a certain range. So I can just explain about the difference array a little bit in a single dimension. Obviously, matrices will be 2 dimensions. So suppose you have like an initial array of like 2, 7, 9, 10, and like no, -1 or something, right? So what a difference array allows you to do is it allows you to perform a range update on a input array, right, in constant time, but in an offline manner. Offline manner meaning you can't process the range update as it comes. You have to pre-process the range updates that you know is going to come ahead of time. So suppose your range updates, let me denote this as R, is given in the format of left to right, indicating the, let's say, the inclusive range and the value, right? So maybe let's say I'll update from index 0 to index 2 with a value of, let's say, -5. Actually, let's make things a little bit simpler. Let's say I'll update it with a value of 5. Let's say I'll do an update on so I updated this. Let's do an update like this. And then finally, let's just update this one. So 3 queries, right? So the next query will be index 1 to 3, index 3, let's say, with a value of 10. And finally, 0, 1, 2, 3, 4, 4, 4, let's say, with a value of 20. Just for illustration purposes. Okay, so how would you do this? What you do is you construct the difference array. The difference array, so this is the input array, right? And I denote the difference array as D. So you construct the difference array that keeps track of the updates at its bounds. So what do I mean by that? First of all, the difference array is of size n plus 1, where n is the number of elements in your input array. So in this case, with 0, with 1, 2, 3, 4, 5, you have 6 elements. So you have like 0, 0, 0, 0, 0, and 0. Okay. So at each point, you record the update that's being made to a particular range. So at its bounds. So if we take a look at query number 1 or range update number 1, you see from 0 to 2. Okay, so we know that if we come into index 0, we will need to apply an update of 5. So we will increment this point by 5. But we also know that as we exit the uh, inclusive bounds of index 2, we need to apply the update no longer applies. So we have to remove the value of 5 or decrement it at index 2 plus 1. So 0, 1, 2, 3. So here we will mark it as -5. So likewise here, 1 to 3. So just speed things up a little bit. 1. So here will be 10. 1, 0, 1, 2, 3 plus 1. So this is -10. Then we have index 4, 2020, 0, 1, 2, 3, 4. So add 20 here. So this is +10. And we would say -20 here. So as you can see, by the time our difference array reaches the last element, usually if you did your updates correctly, it should be 0. So you can see 5 plus 10 is 15, minus 5, that's 10. How should I say? Yeah, 15 minus 5 is 10, 10 plus 10 is 20, 20 minus 20 is 0. So yeah, you can then compute the prefix sum of the difference array, and that will represent the total contribution that's made to a particular element. So for example, let's say we take a look at this one. The prefix sum of this subarray is 15. So the claim is that the total contribution that's made to this is 15. So the resulting element of index 1 would be 7 plus 15. So you can see here, we apply a range update from 0 to 2 with a value of 5 and a range update of 1 to 3 with a value of 10. You do see that, the number of contribution that's made to this index is 15, right? Okay, so how does that relate to today's problem? Well, you can apply the same concept but in a 2D manner. And personally, I've heard of it but not done it before because I heard it is like rather complex. But I'm not sure. Let's see if it's complex. Let's try to do it. If not, we need to do the brute force method where for every query, right, for every query, we probably have to do like n times n. We might have to do n times n work. And n is only up to 500. Oh, maybe 2D, the 2D difference array is the only way to solve this. I'm not sure, but yeah, let's try it. So n times n. Okay. So our difference array has to be 0 or I in range of n plus 1. Then for in range of n plus 1. So it's the same concept here where we have the n plus 1. But in this case, we have to apply it in two-dimensional. We have to apply it in 2 dimensions. So let's create our 2D difference array here like so. By the way, I've not done this before, so let's try it. So for query, so in each query we have R1, C1, C1, R2, C2. Okay, in queries. We also need to have our output array. So our output array, let's do like this. Out is equals to, actually pretty much the same code here without the plus 1. Then we will say the div of R1, C1 plus equals 1. Okay. Then here is R2, c2 plus 1 plus 1, then we say minus equals 1. Actually, I'm not sure about this. Oh, let's see. Let's do a quick example. Let's say the update is like 0, 0, and 2, 2. And then we have like a matrix like, let's say 0 here, 0 here, 0 here, 0 here, 0 here. Okay, so 0, 0, 0, 0. Okay. We say we want to update, we want to increment the values for this, right? So we definitely add a +1 here. So it'll be like this. Or just like this. But I think if we come here, we have to do a -1. If we're iterating like from left to right, top down, right? Okay. So I think we need to put a -1 here. Like this. Then when we come back here, we need to do another +1. Maybe. Is that how it's done? Yeah, let's try it. Let's simulate it. I think it's most likely like that. I'm not sure, to be honest. So we do a 1 here, a 1 here, we do a -1 and a -1. And we claim that this allows us to do the update in constant time. Right, okay, cool. Or in this case, it wouldn't really be constant time as much as it is let's see. Yeah, the update is not constant time, but it will be like ON, because we have to add the +1 here and the +1 here, right? And a -1 here and a -1 here. So, okay, let's say we have processed this query. Let's say we want to do the range updates here. Okay, cool. Let's see whether it will, whether our algorithm will give us the final result. So the next update we want to do is, let's say here, right? That means this will be 1, 1, 1. This will be 1, 1, 1 as well, except for this. Okay, 1, 1, 1. This is 1. This is 0, 0, 0. This is 2 and 2. So these two places will be 2 and 2. Then this will be 1 next. So if we want to apply the range updates here, right, I actually need to add a few more, a few more rows. This. It's not the prettiest, but we'll make do. Okay, so we want to make the update here next. That will be 0, 1. Okay, 0, 1, 2. So it's 1, 2. Okay, let's put it here. 1, 2, and this would be 0, 1, 2, 3, 0, 1, 2, 3, 4. 1, 2, 3, 4. Okay, cool. So index 1 and index 2, we would say this is plus 1. This is plus 1. This is plus 1. Then we would put, where this is zeros. Then we'll put here negative 1. Negative 1, negative 1. It looks correct. So as we iterate from left to right, this will be 1. Okay, so this will be 1, this will be 1, this will be 0, 0, 0. Then this is 1 again, 1, 1, 0, 0, 0. So far, so good. Wait a second. I think I messed up. I messed up. It should be, here is 1. Like so, okay. Because it is index 1, index 2 here. So this is 1 here. This is minus 1 as we exit out the range. Then there's a 0, 1, 2, 3, 0, 1, 2, 3, 4, plus 1. Yeah, okay. So this is 1, this is correct. This is 1, this is 1. Our current sum. And when we add this will be 0. So this is 0, 0. This is nothing here. Also 0. Okay, fine. Then now we add the plus 1. 1, 2. Then we minus 1, so it's 1, 1. Minus 1, okay, but there's no updates here. Then we add the plus 1 here again. So it's 1, 1, 2. Minus 1, which is 1, 1. This is nothing. This is nothing. So we go back to 0, 0, 0, 0, 0. And what's this? We add the 1 here, the 1, 1, and the 0, and then we're done. Do we actually need the final row? Why not? I don't think we need the final row. I don't think we need the final row. So in that case, it would be like this. So this is the output, this is the diff. We'll return out. That means it's actually the row 2 itself. Row 2 itself. Let's make this a little bit nicer. Row 2 itself. Okay, cool. And also this query is updated. Okay, so it's the row itself, and then the column plus 1. Yep, column plus 1. Okay, cool. Then now we just need to process the queries. I mean, process the difference array, right? So we have like the current, which keeps track of the updates that is being made to a particular cell. Then we say for how should I do this? I in range. Let's just use indices. For I in range of n. So this is the number of rows. For j in range of c n plus 1. This is the number of columns. And we say current plus equals diff array of I and j. And afterwards we say if 0 less than equals to I less than n and j 0 less than equals to j less than n. Okay, then we say out I and j is equals to current, then return our output. Okay, looks like we added, okay, at least it's correct for this, I suppose. But it looks like we always why is that? Oh shit, okay, we haven't processed this properly. Yeah, so okay, we mark this as +1, but actually what we need to say is for I, for R, I guess. So it's always like top down, right? Okay, for R, let's see, this is 0, 0, 0, 1, 2, 3 is 0, 3. This is 0, 1, 2. This is 2, 0, and then this is 2, 3. So we need to iterate at least 2 row number of times. For R in R2, in range of R2. Oh, we need to do the +1 here. So R1 plus R, I guess. R1 plus R plus equals 1. Okay. C1. C1 is C1. Then do the same thing here for R in range. Now we have the. I guess we can start from here, right? And work our way downwards. For in range of R2 as well. It's also R2. Div of R1 of C2 plus 1, R1 plus R. Okay, now both of them is wrong. Oh, god dang it. Okay, let's print out our difference array. R in div. One, two, three, 4. Oh, I just realized that. It's fine. 1, 2, 3, 4, 5. Yeah, we can just add another row. I just realized that it's a n times n matrix, so it's always a square. Okay. This is 0, 0, 2, 2. And then this is 1, 2, 3, 4. R2 plus 1. Oh, snap. Isn't it R2 plus 1? Index out of range for this one. Unless you're telling me I need this. Okay, let's see. Um, this is correct. Shit, this is wrong. 111 111 1. There is a bug somewhere. I don't know where. I feel I should not need this. It got the first query correct, that's for sure. But the second query, it didn't get it right. Because like, second query, for the second query, it had like one more row. Okay, let's see. R2 is 3. Hmm. Oh, I see. Okay. So we need to get the height. So it's R2 minus R1 plus 1. Hmm. I think so. Okay. I don't think we need this actually. Print. Okay, let's see. It should be correct. But let's try some random inputs. Let's say this is 10. Then we say, I don't know. Shit, I think. Okay, fine. We have to be careful with our updates as well. Let's say 0, 0, 3, 4. Would that work? Okay, it does work. Let's say 2, 2, 6, 6, 6. Okay, the code seems correct, but basically the bug was here we need to iterate over the height between 2 points. So suppose you have like a matrix here like so. We don't really care about the particular example. It's more about the algorithm behind it, I guess. So suppose we pick these 2 points, right? Instead of iterating through R2, like I was doing before, I should take the difference between them, like so, right? The difference between them and add a plus 1 to get the height. Yeah. So cool. This is the 2D difference array. So what's the time and space complexity? Definitely we need a space complexity of n times n, where n is the number of rows and columns, and our time complexity is also n times n, right? So it's actually all queries times n. So it's queries times n because the difference between R2 and R1 can go up to n plus n times n. So that's the time complexity. I'll say that again. The space complexity is n times n. The time complexity is q times n plus n times n. And yeah, that's it. Let me do a quick submit to make sure that what I said is actually correct. Oh no, did I actually made a mistake? Okay, thankfully not. So yeah, I got accepted. That's good. My first submission as well. Let's put the code on the right side for reference. Like so. Let's see the editorial. 2D difference array plus perfect sum, which is what I said. But I was wondering if we can do the marking in O1 time instead of ON time. Maybe not. Maybe you can, according to. Whoa, whoa. So actually, you can do it. Uh, like you can use the difference array method, but you can do it in O1 time apparently. Let's see. Let's see how they do the marking. I'm quite curious as well, the 2D matrix thing. Like I said, I've not done it before. I've heard about it. If I have to apply the 1D difference array, this will be how I would apply it. But apparently there's a smarter way of doing it. So let's use the same example, but we want to see how the editorial construct the difference array. I'm actually quite curious. So they're all zeros initially. Zero, zero, zero. So the difference array actually has one more row, right? Okay. So let's edit. Zero, 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 zero. And for this particular example, it's more like a 1, 2, 3, 4. It's a 4 times 5 matrix, but it doesn't matter because if it's like n, and if it's like a square or rectangle, right? Okay. So it's the same. This is the output we're expecting. We are doing a update here and an update here. Okay. So the editorial is saying, okay, we can mark the difference here. We can mark it here like so. Put the 1, row 2 plus 1, and the column minus 1. Row 2, that will be here, this one, plus 1. Okay, that will be the third one of column 1. So it's saying here, we do a minus 1, right? So it's row 2 plus 1 of the column 1. Okay. Then it's saying row 1 of column 2 plus 1 minus 1. Row 1 of column... which was 0, 1, 2 here. Do a minus 1 here. And then row 2 plus 1 of column 2 plus 1 plus 1. Row 2 plus 1 of column 2 plus 1. Here, you do a plus 1. Okay. Right? Okay, so let's double check. Row 1 of column 1. That's this. Okay. Row 2, okay, which is here, of column 2, column 1, which is this column, that would be this, 3, 0, minus 1. Okay. The mark here, that's correct. Row 1, which is 0, and column 2 plus 1 minus 1. This is easy enough to understand. There will be this one. And then finally, row 2 plus 1 of column 2 plus 1. There will be this. That's to represent the range updates over this part. The hell? Okay, let's see. So it has the output matrix here. So iterate over n. It only iterates over n. x1. Okay, let's see. The problem asks us to perform multiple increments in a rectangle. I think this might have been a better. Let me upvote this, man. Yeah. Wait, hold on. Let's see the latex. I mean, okay, this is just a code, right? Here, this part. Okay, fine. x1. If I is equals to 0, else you take the previous row of j. Oh, what is this still? Let's look at the visualization, because I feel like there are things to be learned here. Hmm. So I understand about this and this and this, but I do not understand about this one yet. So how they're doing the 2D difference array is, as we update the values for a particular range, right? We actually make use of the resulting array, because that stores information of what we need to compute. So we know that this is our answer, right? Let's put it here first. Do a copy here, donate this. All right, let's erase this. Okay, so we we okay, let's just process the first query. We come here and then we increment it by this, right? takes the difference array plus x1, which is the previous row, and x2, which is the previous column, and x3 is the top left corner. Okay, so this x1, let's see, so for, let's say, oh my god. Yeah, like this is good. So at a particular cell here, if this is our I and j, if this is our I, this is our j, right? X1 is this one. This is x1, the previous row but the same column. X2 is the same row but the previous column. This is x2, and this is x3. This part claims that the output matrix would be whatever is in the difference array, and this particular formula where you add this and this, but you subtract this. Okay, let's see how it works. All right. So we'll use the red circle to indicate what we are currently iterating over. Okay, so we iterate through this, then we add it like this, right? So that will be just be 1. Erase this, I'll put 1. This is 1, this is 1. This is 1, this is 1. This would be 0. That's correct. That would be 0, because we do the -1 here. And when we look at the top left, is this 0? Because it's -1 plus 0. But this should be +1. No, -1 plus 1 minus 0. Okay, yeah, so it will be 0. This will be 0, 0. Now this one, we'll look at this. So that will be 1, 1, 1, 0, 0. So this will add 0 plus here, minus here, which is nothing. This part will be 0, 0 plus this minus this. Okay, which is 1. This one will be 0 plus this minus this. Okay, this part will be 0 plus this minus this. Okay, wow, okay. So it will be the same for this row. But why do we need to mark it here? So this is +1 plus 0 minus 0 +1 plus 1 minus 1 plus this. Okay. Yep. Okay, now it's here. Here is -1 plus 1. Yep, -1 plus 1 minus 0. Plus 0 minus 0, that's 0. How about this part? This part we have 1 here. So it's 1 plus this minus this. Oh, and you get 0, which is correct. Why does it work? Not really sure as well. Okay, let's see the G. Biodynamic gate reset. Unfortunately, it is what it is. Okay. Yeah. Okay. Yeah, I'm not sure. Like, I understand it. You probably have to watch like another video to explain it properly, me included. But basically, it makes use of what has already been previously computed and stored in the output matrix to derive at some optimization by looking at its uh, three corners, I guess, of a particular cell that we are considering. Like this is the cell we're considering. You'll look at the top left and the top. We'll look at what's on top, what's on the left, and what's on the top left. But why does it work? Why does this shit works? Yeah, I'm not sure. Anyway, uh, this is the editorial's code. Just show it here. I will definitely study this today. And this is my code, which is apparently not the right way to do 2D prefix sum. But yeah, I hope you maybe learn a thing or two or not. Thanks for watching and have a great one ahead.